Welcome to the Stormsurf video surf forecast for the week starting Sunday, January 7th. Looking at significant wave heights for the North Pacific Ocean, we see a better pattern than we've seen in quite a few weeks. A gale, actually a storm, developing over the dateline, 40-foot seas, aimed to the east-northeast, targeting the U.S. west coast pretty well, and also sideband energy pushing towards Hawaii is just the start of a stronger system that is supposed to be wrapping up in the next day or two. Also, notice small energy off of British Columbia and the Pacific Northwest, 18, 19-foot seas, pushing towards the U.S. west coast, but of no real concern at this moment. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help directs their track. We're looking for a trough, a dip in the jet, and we have two of them. One right here and one right here. This one here is the stronger. Notice winds pushing off Japan, moving to due east. Winds, what is that, about 180 knots. That's feeding the trough. That helps support a counterclockwise flow aloft. That's the hallmark of low pressure, and also down at the surface. And of course, low pressure generates wind, winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, creates surf. So, one potential area here. Also notice another dip right here. Same deal, supporting low pressure off the U.S. west coast. And yet another way down here. It's actually generating some minor seas. This is basically a cutoff low. Notice the jet stream is split. And well, let's talk about that. Here is the split point. Pretty much all year has been somewhere between 155 and 145 west, somewhere right in this area. And it's doing that still. Notice the northern branch pushing up into British Columbia, southern branch falling south, and then sort of splitting or doing something strange, part of it pushing up into California. And typically between these split flows you get high pressure, but there's a little bit of a trough here, just enough to maybe start generating some low pressure of no real interest, but something to monitor. Anyway, so let's go take a look at what the forecast brings for us. So the trough continues pushing east into Monday morning. The trough in the Gulf starts pinching off. The trough that was further south starts lifting north here. This is what is supposed to be the rainmaker for California on Monday into Tuesday, and maybe produce some snow in the mountains. Anyway, roll this out. The trough in the Gulf pinches off, but look how far south it is. It's down off of Point Conception on Monday night. So one trough pushing in. Looks like another getting ready to come in right behind it. Double whammy. And this one probably would be more energetic. Typically notice how much more energy is feeding into it as compared to the previous trough. And of course, our trough over the dateline kind of starts fading come Monday night into Tuesday. And there you go. Look at that. Backdoor. It's not a backdoor trough. It's front door trough pushing right over, well, looks like Point Conception area. Come Tuesday morning, that should make for some rather stormy conditions, certainly into Southern California, south of that trough, because remnants from the previous trough are over there as well. So good dose of wind, upper-level wind energy, and that typically produces weather, but also up into Northern California as well. Now, also notice, at the same time, 190-knot winds start building off Japan. So we have the fading remnants, our first trough, and we're willing to bet that this will help create yet a second trough, which could support storm and gale formation. Anyway, so let's roll this out, see what happens. There you go. We have 1, 2, 3. That gets you 210-knot winds. Those are very strong. That's a good, solid jet stream flow. And notice, yes, there is sort of a split thing going on here out about 160, but very minor. The jet, for the most part, is almost consolidated, pushing the whole way across the Pacific. And that is even more interesting, seeing how the inactive phase of the MJO is developing over in this area. So, you just never know. We've never said that the inactive phase of the MJO cannot support storm formation, but odds typically are not in its favor. We're beating the odds right now. We'll take that. Any swell generation is good. Any weather generation is good. Also notice the jet stream here pushing into the Oregon, North California border Wednesday. That probably means precipitation up into this area as well. All right, so roll this out. Here we go. Next trough starts building on Thursday over the dateline, Western Gulf almost. The jet stream split, but most energy pushing into the Pacific Northwest. That's looking good. There we go. There's our trough on Friday. That with good, strong 190, 200 knot winds in the western Gulf. That should certainly support gale formation, if not storm formation. Bit of a ridge develops over California. Things drying out more than likely come Friday. But here comes this next trough. Let's see what it does. Looking very well organized coming the weekend into Sunday. But still, see this ridge here? That's high pressure. That supports a clockwise flow underneath it. And that would be high pressure, high and dry in California. But Pacific Northwest, not so much. Anyway, roll this out. Let's see what happens. And the ridge continues 180 hours out into Monday. But still, good, healthy jet stream flow, consolidated the whole way across the Pacific. Yeah, some sort of a split going out here at maybe 135 west. But good amount of energy pushing into the, this time now, British Columbia or so. So, jet stream looking good. Odds for swell development looking much better than they have so far this winter. Let's get into the details. So we're going down to the surface now. As usual, surface level pressure, surface level winds, and as expected, a storm. That dark red there, that is 50 to 55 knot winds. That qualifies as a winter storm, not a gale. Gale's less than 50 knots. So officially, winter storm on the dateline. There's the dateline right there. Pushing off to the east, fetch actually from the northwest, so that would be aiming, yeah, probably somewhere off in this region, a little bit east of Hawaii. Still, Hawaii should get solid swell from that. And certainly at the U.S. West Coast. Also notice low pressure pushing into British Columbia at the moment. Roll this out. Oh, look at that. 55 knot winds, maybe even more on the dateline come Sunday night. That's only 12 hours out. That is 10 o'clock Sunday night. So basically right around now. Continuing lifting north. 50 knot winds into Monday morning. That's a pretty good long stretch of solid storm force fetch aimed to the east. Swell should be generated well from that. Also notice low pressure. Remember, we saw that sort of complex trough situation off the U.S. West Coast, California. Low pressure right there. You can see it moving into the coast. We'll take a closer look when we zoom into the California portion of the forecast. Anyway, the gale continues as we get into Tuesday. 45 knot winds. Next gale queuing up off Japan and rain into California Tuesday. That fades out. Next gale sets up off the northern Kuril Islands, 45 knot winds, and then by the time you get into Wednesday morning, 50 knot winds pushing off the Kuril Islands, pushing across, now it's down to 45 by Wednesday night, pushing towards the dateline. On the dateline, 45 knot winds, a broad area of fetch, 35 knot, probably, you know, just eyeball it, say 1,000 miles of easterly fetch aimed at the U.S. West Coast, California, under high pressure. Reorganizes come Friday. 45 knot winds on the dateline. Again, sort of pushing a little bit east of Hawaii, more at the U.S. West Coast, but from a good distance away. That gale, look at just a broad area, almost filling probably 50% of the northern tier of the North Pacific, and continues into Saturday, slowly fading out, losing momentum front off the U.S. West Coast. High pressure holding it at bay. Offshore flow on Sunday. That's looking very good for California. North winds, it looks like, for Hawaii. Roll this out some more. We're into 180 hours out. Maybe the gale redevelops off the U.S. West Coast. Hard to say. Things dry up in the west. Maybe this is the last pulse before the inactive phase of the MJO takes over, but you never know. Though, 2 is what it's looking like. 2 solid storms in the 180-hour forecast. Let's go take a look at the effect of those winds on the ocean surface. And here we go. Significant wave heights, North Pacific Ocean. Again, here we saw this, just a tiny little area right there. 40-foot max seas over the entire region, defined right there, and their location. Max winds, 54.7 knots, right in there. So that's telling us already we have a storm with nearly 40-foot seas. That's nothing. This thing really winds up, wraps up into Sunday night. Here we go. Monday morning, 52-foot seas. Yeah, that's about it. 52. Actually looks even a little bit higher than that. No, right about 50, 52. Good solid. Now, north of 45, north pretty north-angled swell to result. Most of this thing is, when you see it, it only starts really building once it gets north of the 45-degree latitude line. So relative to California, it'll be a little bit more of a northerly angled swell. Long period should result if we get this. If you have 50-foot seas, you're going to see at least probably a 25-second period, leading edge energy off that. Maybe not much size, but 25-second period. And then anyway, we're going into Monday. This thing finally fades out, but then redevelops a little bit. Small area of 32, so 33-foot seas. So a couple of days of swell for sure, and still holding on. Next system develops come Wednesday, and right up to 40-foot seas on. Now, this is much further away. Should do pretty well for Hawaii. We'll see how this thing builds up to 45-foot seas. Little bit broader area, 44-foot seas into Thursday, making it over the date line with 41-foot seas, then starting to fall a little bit to the southeast, aimed very well at Hawaii with, again, 43-foot seas. This guy, in fact, let's just see how far this goes. Okay, finally fades out there Friday night. So we'll just go, what was the duration of 40-foot plus seas? Starting there from Wednesday into Wednesday 12Z to, there we go, to Friday 18Z, 48 plus hours, maybe 54 hours of 40-foot seas aimed east. Certainly going to get a swell from that if it materializes as forecast. And then slowly continues. Look at this. I mean, you can just see this wall of seas pushing towards Hawaii, overtaking Hawaii, then pushing towards the U.S. West Coast as we get into Sunday. We know there's a bunch of wind energy hanging out here too. And there we go at 180 hours. We're out and seas starting to develop again in the Gulf of Alaska. Hawaii just getting bombed with swell size. What is that? That's probably just eyeballing it. That's looking to be 15-foot seas. We're not talking about period, just raw seas. Probably don't want to be out in a boat in this area come next weekend if these models are holding true. Very impressive. Now let's zoom a little closer. Let's take a look at winds. We're mainly looking at California, but Hawaii. Trades in effect, blowing pretty good, 15 knots at the moment. Light, beautiful, actually, beautiful ocean conditions, surface conditions in California today. Sky was cloudy, but offshore winds, Ocean Beach had fun, small surf. Not a bad day to be alive. And we roll this out into Monday. The storm starts organizing. South winds relative to California. Trades hold for Hawaii. You can see the lows. Again, rotate counterclockwise around the low pressure. That would mean south winds in front of the low, north winds behind. Classic example of it right there. Anyway, okay. And so there's our low winding up Monday night. Look at this. It's right off, almost over San Francisco come Tuesday morning. We're not looking for good surf conditions at all. Things will be a very, very tattered mess. We even see 20-knot winds pushing into Southern California Tuesday morning. Trades holding for Hawaii, though. That's good news for them. The low moving over Point Conception and inland Tuesday night. Looks like high pressure is behind that. Remember, low pressure here, rotating counterclockwise. High pressure, rotating clockwise. The closer they get together, you get a gradient. That's what makes these winds. The tighter the isobars, the stronger the wind, up to 30-knot winds off the coast, but will make for indefinitely mangled local surf conditions. Winds southeast still in Hawaii as we get into Wednesday. Northwest winds, I mean, California just doesn't look so good. Monday, Tuesday, Wednesday, not so good. Let's see as we get into Thursday. Trades hold relative to Hawaii. As we get into Thursday, a lighter northerly flow. Now, this hot, kind of low-res model typically understates the strength of the winds, and it's hard to tell exactly what's going to happen in all the nooks and crannies. But it looks like Thursday, winds lighten up a bit. High pressure starts ridging into the coast. Point Conception, though, probably still a bit windy there, but up into Northern California, not so bad. Rolling this out, light trades continue for Hawaii into Friday. Looks like almost an offshore pattern setting up Friday for California. Into Saturday, look at this. A wall of storm, winds start turning south. Looks like a front heading for Hawaii. Offshore flow for California Saturday. Northeast winds into Sunday. North winds for Hawaii, of course. Here's your secondary low developing off the coast. And where are we? Offshore flow for California into Sunday. And into, where are we? There's the end of the model. Monday, light winds, not bad. Hawaii trades trying to get established. We'll see what this guy does. See if any of this comes true. But anyway, you get a general sense. Okay, let's do a quick look at precipitation. Here we go, GFS precipitation, California here. We're doing this mainly for the benefit of California. You can see come Monday night, maybe some light drizzle. The rain starts in earnest on Monday. Looks like almost from San Diego the whole way up to Cape Mendocino. The focus, though, looks like the San Francisco Bay Area. Snow in the southern Sierra, probably only in the highest elevations. Roll this out, continuing pretty good, healthy dose of rain come midday Monday into Monday night. Look at that, very strong. Again, no real snow indicated for the Sierra except in the very highest elevations. Tuesday, same deal. Pretty good rain event, even into Point Conception there. Getting, actually, let's go back. Yep, that's the start of it for Southern California. Point Conception, pushing south and through, well down past San Diego, rain. And then colder air starts working its way in. Looks like snow for pretty much all of the Sierra, mainly starting at Tahoe and southwards of there, rolling that out and then drying up come Tuesday night. Wednesday, dry conditions for the most part, except for mainly extreme northern California. And then after that, focus turns back towards the north. Canada, northern tier states, down into Oregon or so. And then we'll just roll this out. The thought is high pressure takes control and everything is going to get deflected to the north from there. And there you go. Let's take a look long-term, see what's going on. Let's see what's happening with the MJO, see if we can divine some sort of a sense for the long-term forecast. First up, MJO status. We look at winds across the equator. Here's the equator. This is in the Pacific. West Pacific here, East Pacific here. That's New Guinea. You can see actual winds. This is derived from the TAO buoy array, series of buoys strung across the equator. And so this is 5-day average winds. And you can see trades, east winds over the entire region. The Kelvin wave generation area from 170 west on over to about 135 east, 5 degrees north and south of the equator. This is the main area for monitoring the development of El Nino, also the production of Kelvin waves, and also for monitoring the status of the Madden-Julian oscillation. It is the anomalies, differences from normal for this time of year, that really tells the story. Calm winds are normal, I shouldn't say calm, normal anomalies, nothing different from normal in the East Pacific, but in the West Pacific, in the Kelvin wave generation area right here, you see easterly anomalies. That is a classic sign of the inactive phase of the MJO, and we know already that the inactive phase of the MJO is building in the West Pacific, so one would expect easterly anomalies to be in control. When you're in the active phase of the MJO, winds reverse, or they turn westerly anomalies that wise. I mean, typically winds will just slacken, but that's what sets up westerly anomalies. That imparts energy to the jet stream, and that in turn feeds the storm track, and if it's strong enough, also pushes rain and wind into California. Wind forecast for the Pacific, 850 millibar zonal wind anomalies. These winds up about 4,200 feet, maybe 4,500 feet, something like that. So this is the entire globe on one planet, the Kelvin wave generation area. So this would be the West Pacific here, date lines right here. So you just look down this chart between these two tick marks to see. The reds and the oranges are westerly anomalies. So this would, looking at this, one assumes that there was the active phase of the MJO here in mid-December, towards the end of December. Then you see as you get towards the later part of December, the blues are easterly anomalies, the building inactive phase of the MJO, which started really in earnest on January 5th. Strong easterly anomalies in control. And oops, there you go. So there's your tick marks. Kelvin wave generation area from there to about there. We're in the heart of the inactive phase of the MJO, but looking at the jet stream, you would know it. It's acting like the active phase of the MJO is in control, and that is what is to drive, of course, our storm track. Anyway, inactive phase supposedly slowly, or the easterly anomalies associated with it, slowly moving off to the date line come the end of the week, 14 days out, 14th of January, but still, basically, easterly anomalies filling the Kelvin wave generation area. The expectation is somewhere in this window, maybe a week out or so, the jet stream will probably fall apart, and that'll be the end of our storm track. That could help usher in a pattern change for the Gulf of Alaska, maybe help break down high pressure. No guarantees, might even feed it. So, but typically, any sort of a change as significant as this, one would hope would have a detrimental effect on the blocking high pressure ridge that's been the bane of California's winter. So this model, this is outgoing long wave radiation, hasn't updated for a week now. We probably need to talk to NOAA, see if they even know that it's down. But anyway, their forecast from a week ago showed these oranges and yellows. So here's the West Pacific, East Pacific, South America, Australia, New Guinea, showed that the inactive phase of the MJ was building and moving off to the east. The GEFS model basically showed the same thing. More sunlight reflectivity off the ocean surface, positive values, meaning high pressure, meaning the inactive phase of the MJO. With the active phase of the MJO hold up, less sunlight reflectivity, meaning more clouds, and that all balled up in the Indian Ocean. So supposedly, here's where we are right now with the inactive phase of the MJO over the dateline per both models. Phase diagram charts, too, for whatever reason, are hung on January 1st, so that's not giving us anything. At that time, the active phase of the MJO, right here where the heavy dot was, it was in the Indian Ocean. Both charts and forecast to basically slowly be tracking east, but staying in the Indian Ocean for the next 2 weeks. So the thought is the inactive phase is on the other side of the chart here, out towards the dateline, and we assume that to be the case. Good news is the upper level model right here, this jet stream level model, propensity for precipitation. So the oranges, yellows are drier conditions, and one can assume that, and this leads what happens at the surface by about a week or two. So the you can try New Guinea there, South America there, Australia. So a little bit east of the dateline is, one would assume that's the inactive phase, the MJO, and it moves off to the east and over, again, here's the equator, so into Ecuador, let's say somewhere around January 25th or so. At the same time, the active phase of the MJO, a very weak one, the green's propensity to support precipitation, start building in the West Pacific about mid-January and easing off to the east. That would suggest that a enhanced storm track, or at least a better support for storm development, maybe towards the end of January, and that moving into Central America by first to second week in February, and then here we go all again, inactive phase developing off of the West Pacific, the Philippines, and moving off to the east into mid-February. So a pretty good regular pattern. Inactive, active, inactive, but the bias is towards the inactive. They look stronger, and that's typical of La Nina. La Nina favors the inactive phase of the MJO. El Nino enhances or favors the active phase of the MJO. And of course, the trusty CFS model, 850 millibar wind anomalies. So here's where we are today. This is the whole world on one world on one chart. Kelvin wave generation area, 120 east, so about 130 to 170, right in there. You can see the blues, easterly anomalies, and the forecast is moving forward. Past performance is back here. This is our active phase, westerly anomalies in the moving across the Kelvin wave generation area in December 22nd time frame. Now we're in the inactive phase. In fact, we'll just overlay this. Oops, there we go. Bingo. The dotted contours are the inactive phase, the MJO. So we're just getting our way into the inactive phase. It's supposed to peak, let's say, January 10th through about the 15th or so, 16th. So we're still a little bit out from that. One would expect the storm track, of course, to back off at some point as this becomes more established. And then, but the good news is, here's our active phase of the MJO, expecting to move into the West Pacific, January 16th, 17th, something like that. Westerly anomalies building pretty good at the end of January up into almost mid-February or so. So that would be the window for favorable potential for storm development and enhancement of the jet stream at that time. So the thought is, whenever this storm track, the series of storms that we have right now, we got about a week, 2 weeks worth of swell. Well, by the time the swell gets here, let's say 2 weeks out. So after that, there'll probably be a bit of a lull. That's when you should go take care of your chores, get ready, and then the next pulse would start sometime in probably first week of February or so, and continue through the month of February. After that, inactive phase sets up again, but notice not so much easterly. Look at that, that's a strong easterly anomaly signature there, not nearly as strong as one forecast with this next inactive phase out in March, but by then we'll be into spring. Relative to California, high pressure should be building strong, north winds ripping down the coast. Clean swell will be hard to find. Make the most of what you can get when you can get it. Anyway, okay, low pass filter. What's going on? What's the really long term? What's going on? Just the most generalized thing in the atmosphere. Okay, dotted contours here mean the propensity or a bias towards high pressure over the Kelvin wave generation area right in here. So the eastern half of the Kelvin wave generation area is under this La Nina bias, if you will. But notice, once we get into March, that's supposed to quickly move off to the east. That is theoretically considered will be the end of La Nina. And here's the low pressure bias that's been in the Indian Ocean for 2 years now. It's finally supposed to start moving east and almost filling the Kelvin wave generation area come April. Of course, we're done with winter by then. Won't do much for us, but at least it signals perhaps the end of La Nina. Just a quick look here at the inactive or active. This is the strength and the consistency of the active phase, the MJO. Somewhere in, when was that? November or so, big active phase of the MJO, and another, just these sort of steady peaks of the active phase of the MJO, even into, well, this lags a little bit, but you get the sense. The December active phase of the MJO, we're sure that'll bottom out. We'll be down here somewhere as soon as the inactive phase takes hold. Anyway, you can see back this summer, we had literally no MJO activity. That might explain why the southern hemisphere was so quiet. And theoretically, the northern hemisphere has been pretty quiet too until this latest series of storms that are on the charts. I mean, there's been consistent small surf, especially north of Point Conception, but just nothing significant in size. All right, what's going on in the ocean? West Pacific here, East Pacific here. We're looking at temperatures at depth. You can see warm water, 29 degrees centigrade, all in the West Pacific. The East Pacific, whatever warm water there is very shallow, very weak. That's the hallmark of La Nina. Here's anomalies, differences from normal for this time of year. And what we see is cooler than normal water was at 3 degrees below normal, but this is getting shallower and moving more off to the east compared to months past. And notice warm water starting to push off here. We're tracking this line right here to see if this is possibly a Kelvin wave. Can't imagine that it would be, but there were some west anomalies from that last active phase of the MJO, and that's what happens. You get a slackening of trades here, or you get out and out westerly anomalies. That takes warm water that's here and starts pushing it to depth and then across the Pacific at depth down 150 meters. And if it's a real Kelvin wave, it eventually gurgles up to the surface off of South America and starts warming temperatures here. If this were to be a Kelvin wave, that might put a serious dent into the cool pool sitting off of the South American coast right now. We don't believe it is, but you never know. Could be. Here's another view, a little bit, basically it's the same data modeled a little bit differently, but you can see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. They say this is 4.5 degrees centigrade above normal. That is certainly warm, and we can see we were watching this just yesterday. Even though it says January 3rd, it updates every day, and the warm anomalies are making eastward progress. Now here is the cool pool. It's getting steadily shallower, and the core of it is moving progressively towards the surface and towards the east. As soon as it gets high enough up, of course, in the ocean, you remember you have strong trades blowing here. All that will just upwell to the surface, and then maybe it will allow opportunity for warm water to sneak in behind underneath it, if this were a real Kelvin wave. Sea level anomalies, strip out. So basically, this JSON 2 data, strip out all the waves, strip out the wind swell, strip out the tides, strip out anything else. You see still, we have negative 10 centimeter, minus 15 centimeter anomalies here. So what that means, cool water at depth, cool water contracts a little bit, creates a little bit of a divot on the ocean surface. Just another way to verify what we saw in the other charts. Also notice positive anomalies here in the West Pacific. There's New Guinea right there. There's Australia. We're only concerned right on the date line here, 5 degrees north and south. But this is the Kelvin wave generation area right here. That's where all your warm water is. All we need is good westerly anomalies to maybe create a Kelvin wave and take some of this warm water, push it to the east. And that's what appears to be happening at the moment. All that looks somewhat positive, but let's go see what's going on at the surface. And really, not a whole lot has changed. Here we go. Here's Peru, Chile, Ecuador right there. The blues are cooler than normal water temperatures, anomalies cooler than normal. But also notice here we have warm anomalies starting to build off Chile and up to southern Peru. They haven't built any further. Actually, this right here will say maybe that is a little bit of warm anomalies off of central Peru, but also notice very close to the coast, there's still strong southerly winds blowing here, creating upwelling. You see that? And it's like the cool flow is just going right out and along here. Very broad area of cooler than normal water. Moving into the main El Nino, La Nina monitoring region starts at 120 west and goes out to 175 degrees north and south. But it all really starts originating over here, especially if you get strong easterly winds going. Remember, high pressure down here in the southern hemisphere, rotating counterclockwise. High pressure in the northern hemisphere, rotating clockwise. The two of them, when they converge, sets up those trades roughly on the equator. And when both the highs are stronger than normal, and that's what happens during La Nina, they blow harder than normal, create upwelling, and you get this cool pool setting up right here. And we also know we have cool water at depth as well. Anyway, pretty cool. Not cool like it's cool, but cool pattern in control of the East Pacific, the hallmark of La Nina. 7-day trend, you can see it, slight warming continuing off of Chile and Peru and to the Galapagos. And there was a lot of cooling out in here. Steadily, these little pockets of cooling are getting smaller, fewer, and far more distance between them, suggesting maybe that La Nina has reached its peak. But this is only a 7-day trend. Looking at the big picture, La Nina is still very much in control. The main El Nino, La Nina monitoring region, 120 west out to 170. You see nothing but cool anomalies in this entire region, 5 degrees north and south of the equator. So La Nina still in control, but there's our little bit of warming. You just get the sense that maybe, it doesn't look, certainly down in this region, nowhere near as robust as it was. You get the sense that in the heart of where La Nina is being generated, that things are starting to slacken off or fade a little bit. Now, that could just be because the active phase of the MJO has been in control. We'll know more as the inactive phase of the MJO sets up. So El Nino, La Nina, they pulse based on the status of the MJO. Right now we're in we were in an active state of the MJO, so that would sort of put a damper on La Nina. We'll see whether it wakes up and starts raging again or whether it just kind of starts fading out. So what is the effect of La Nina on the atmosphere? Is it doing something? We look at the Southern Oscillation Index. So there's this yin and yang, sort of the atmosphere reinforces what goes on the ocean reinforces what goes on the atmosphere. Then sometimes they get out of sync and the ocean's doing one thing and the atmosphere is doing something else. And when that happens, it makes you think that maybe a pattern change is coming. So we look at, this is the difference in pressure between Tahiti and Darwin. When the anomaly or the index is negative, that is typically meaning more low pressure over Tahiti, higher pressure over Darwin, which typically means the active phase of the MJO. We know that in December, look at all those negative numbers, the active phase of the MJO was in control. Now we know as we got into January, the active phase, and look at the positive numbers, are starting to set up. But just the past couple days, look at these, a couple of negative numbers showing up. Makes you kind of wonder what's going on a little bit. Anyway, the 30-day average Southern Oscillation Index. So this you can use. This is good for looking at the MJO, active or inactive state. When the index is up at 10, that would typically tell you inactive state. But look at that. In December, it just fell and fell and fell. But we know why it did that. The active phase of the MJO was in control. And it went negative and more negative and is still going negative to date. Kind of making you wonder, well, yeah, supposedly the inactive phase of the MJO is going on, but the data is sort of telling us something else. All right, 90-day Southern Oscillation Index, then that takes you out to the next longer cycle, La Nina, El Nino. La Nina, we are at 9.44, but look at this. It's steadily been falling. If this is La Nina at 4.4, that's not much of a La Nina, but of course, we've had a pretty long-running active phase of the MJO. This could always rebound. Here's the 30-day SOI graphed out, and you know, we were in El Nino back in 2016. 2017, the index went positive, meaning La Nina, but not very much La Nina. It was almost neutral last year, and now here is our La Nina, still not particularly strongly positive, but and each of these downward spikes is the active phase of the MJO. And look at this, we're in a very good deep one right now, meaning it's really taking the sails out of La Nina, sort of dampening it significantly, and we think that that's part of what's going on. And then there's the ESPI index, very much like the Southern Oscillation Index, but rather it measures the difference of precipitation north of Australia versus north of Tahiti. The current index is minus 0.95, meaning less, almost one standard deviation of precipitation less in this area here, which is the typical sign of La Nina. And one would expect that to be the case because we know that there's lots of cool water right in this area. And of course, cool water doesn't support evaporation. And you got to have evaporation if you want precipitation. And all that evaporation eventually it's imparting heat energy into the atmosphere, and that's what feeds the jet stream, et cetera, and feeds the storm track. Anyway, index minus 0.95. We want to see this guy go down to about minus a half, and when it does that, then that will, because this leads what happens by about 3 months. If you see this guy, like when this guy first went really negative, like minus 1.5 or something like that, and this was last year, and the ocean still was acting like sort of like El Nino, and then within 3 months, boom, the coup pool developed off of Peru, and La Nina became evident. We're hoping now when we see this guy start either going to minus a half or even neutral, then that would be the clear sign of the end of La Nina, and then a shift in the pattern change across the globe would start happening, pushing more towards a neutral pattern. Then finally, sea surface temperature forecast, Nino 3.4, the official monitoring region for El Nino La Nina. And here we are, January 2018. The temperatures looked like they bottomed out right in the, let's say, November time frame at minus 0.8 of a degree, minus 0.75. That's not too much of a La Nina. It actually looks worse than it really is based on the numbers that we're seeing pretty much everywhere. In fact, here's actual data from the Nino 3.4 region. So you can see it, this is updated daily, and it really bounces around. But back in the November time frame, Yeah, this looks more like 1 degree below normal per this index, and it's still not looking good. The current value minus 1.014, so that's that dot right there. You know, you got to kind of average all this out, but still it's hovering right around 1, so I'd say almost this index is almost understating what's going on, or the other index is off a little bit. Anyway, so the forecast, this model says temperatures slowly rising to minus 3.5 tenths of a degree below normal in July, which is not La Nina. You need to be down at minus half a degree, but still normal biased cool come July. Guess we'll see. This is probably the most conservative of all the models. Many other models have temperatures rising to neutral or even above neutral, so we'll consider this the worst case scenario. So to wrap things up real quick here, so wave models, atmospheric models, jet stream models, all looking very good, suggesting development of 2 storms, probably the 2 strongest storms of the winter, back-to-back forecast the coming week. Swells to result, certainly targeting Hawaii, certainly targeting the U.S. West Coast. Make the most of it while you can, when and if it happens. Again, a lot of this is still forecast data. Could change, probably will change. Won't be as strong as what's forecast, but you never know. Anyway, long-term inactive phase of the MJO. Expect to take over, probably putting a damper on the storm track for a couple weeks after that. Hopefully that will set up a local pattern change, ushering in a little bit more precipitation for California, but who knows? We'll see. And then, of course, right now, we're still in La Nina. We knew this winter wasn't going to be great, and it's not turning out great, but that's the price you pay for, was it 2.5 years of El Nino prior to that. If we can get through this winter, then the pattern should be a bit more favorable. Anyway, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.